What's up, gun lovers? I'm your host, and today we're ripping open the mechanics behind top 5 AR-15 alternatives to show you, in plain engineer speak, why these rifles think they can outperform the AR. I've fired, torn apart, and run dirty room torture tests on every one of these platforms, so what you're about to hear is hands-on, not forum lore. In this intro, I'll tell you what to expect. We'll dissect operating systems, compare materials and manufacturing, think cold hammer forged barrels versus cheap stamped receivers, and measure true modularity, not marketing copy. I'm zeroing in on the nuts and bolts that actually change performance on the range and in the field, how the gas system times the bolt, what the carrier mass does to recoil, and which design choices trade accuracy for indestructibility. If you want the kind of deep, practical breakdown that helps you choose the right tool for the job, hit subscribe. We're about to get greasy. I'm not going to sell you nostalgia. I'll show you the engineering reasons this platform keeps working when everything else chokes. At its heart, the AK uses a long-stroke gas piston. Piston, operating rod, and carrier travel together as one mass. That's a brutally simple mechanical choice, and it buys you forgiveness. Dirt, carbon, and debris don't have to be chemically tamed. They just get shoved around by mass and momentum. From a construction standpoint, look at the receiver options: stamped versus milled. Stamped receivers are cheap, light, and ridiculously easy to produce at scale. Milled receivers are heavier, but give you a stiffer platform for the trunnion and barrel, which matters for repeatable harmonics. Barrel production and rifling quality are where AKs historically lag, but modern manufacturers have tightened tolerances and improved barrel treatments, phosphatating, nitride, etc., so the accuracy gap narrows for practical ranges. Mechanically, long stroke means more reciprocating mass. That changes the recoil impulse and the timing of the action. You get robustness at the expense of the kind of microscopic stability that competitive marksmen hunt for. Also note, the AK doesn't rely on a buffer tube, which opens up folding stock ergonomics, but it also complicates modern modular upgrades. Quick change-uppers, free-floating handguards, and standardized rail geometry are not native strengths of the AK architecture. Field implications. I've run AKs through mud, salt spray, and deliberate neglect. They keep running. But if you're building a kit to accept optics, precision rails, suppressors, and caliber swaps on the fly, the stock AK architecture fights you a little. In short, design choice equals reliability by simplicity. If that's your mission profile, you can trust the long-stroke concept. If your mission is max-out modularity and sub-MOA groups, you'll pay the price elsewhere.
Now flip the script. Instead of glorifying brute force, let's admire clever packaging. The Steyr AUG is a classic bullpup solution. It's about preserving barrel length while collapsing overall weapon length, and that single design decision ripples through every engineering choice on the gun. Bullpup architecture moves the action and magazine behind the trigger. The obvious win is compactness with full-length ballistics. The trade-offs are all mechanical and ergonomic: trigger linkages, ejection path, and balance change. The AUG tackles those with a compact, integrated receiver and a trunnion design that centralizes stress around the barrel. From a materials perspective, Steyr leaned into polymer receiver ergonomics bonded to hardened steel trunnion assemblies. You get weight savings without sacrificing the rigidity needed to maintain barrel harmonics. Most importantly for performance, the AUG uses a short-stroke gas piston. Short stroke means the piston gives the bolt carrier a sharp impulse, then stops. Lower reciprocating mass, less carried momentum, and therefore superior potential for accurate follow-up shots when compared to long-stroke systems. It also limits how much heat and carbon make it into the bolt carrier group, which helps long strings of fire stay consistent. The A3M2 evolution is the interesting bit. Steyr added a free-floating handguard and modular barrel kits, 9mm conversions, 300 BLK, heavy barrel options. That addresses the classic bullpup criticism: not modular enough. Free-floating the barrel reduces interference with harmonics. Conversion kits make the platform more mission flexible. Operationally, you'll trade some immediate muscle memory. Reloads and hand placement take practice, and if you rely on iron sight radius, you'll notice the difference. But functionally, the AUG shows how a well-executed bullpup with short-stroke piston engineering can deliver both compactness and surprisingly consistent accuracy. If your priority is compact firepower with engineered stability, the AUG's architecture makes a hell of a case. About the Mini 14, which is weirdly underrated from an engineering perspective. Don't let the Mini fool you. This design borrows DNA from the M14, but deliberately strips complexity down to a brutally usable core. That choice shows up everywhere. Simplified gas system, straightforward bolt and lockup geometry, and a receiver nose profile designed for durability and easy maintenance rather than bench rest perfection. Mechanically, the Mini 14 is a gas-operated platform with a relatively conservative gas port and carrier timing. Early models used a tilting or rotating bolt arrangement influenced by the M14 lineage. Modernized Mini 14s tightened tolerances, upgraded barrel manufacturing, think better rifling and cold hammer processes on later runs, and improved bedding, all of which close the gap on accuracy without sacrificing the platform's core simplicity. From a materials point of view, Ruger kept things practical. Serviceable steels, robust heat treatment, and conservative chrome and nitride treatments that favor longevity over boutique performance. Where the Mini 14 shines in the field is maintainability. You can take one apart with minimal tools, inspect wear surfaces, and be back on the line quickly. That's not trivia. It's a design decision that trades ultimate modularity and accessory ecosystems for serviceability and predictability. Mounting options used to be a pain, top-of-receiver ergonomics weren't AR-friendly, but aftermarket rails and modern Ruger offerings have largely addressed that, giving you optics without re-engineering the entire receiver. There's also a human factor worth noting: perception. In certain defensive scenarios, the Mini 14 presents differently to witnesses or jurors than an AR platform. Again, not a mechanical advantage, but a real-world variable that impacts choice. From an engineering standpoint, though, the Mini 14's appeal is simple: lineage-proven geometry, durable materials, and an emphasis on fix-it-in-the-drit. If your checklist prioritizes reliable, easy-to-service hardware with respectable accuracy, the Mini 14 is quietly clever.
Let me be blunt. The Bren 2 is the textbook on how to do a short-stroke piston rifle without sacrificing accuracy. The designers started with a goal: marry the reliability of a piston system with the tight shot-to-shot performance people expect from modern combat rifles. And the engineering choices reflect that objective at every joint and mating surface. At the heart of the Bren 2 is a short-stroke gas piston with carefully tuned timing. Unlike a long-stroke system that drags mass across the action, so the bolt carrier sees a clean, repeatable input. That reduces carrier motion variance and helps keep harmonics consistent, which is why you see designated marksman variants putting sub-MOA groups off the shelf in service-grade configurations. The bolt, carrier, and gas path are machined within tight tolerances and heat-treated to control wear and timing drift over thousands of rounds. Material choices echo that precision mindset: high-quality steels for bolt and barrel, nitriding or similar surface treatments to resist corrosion and erosion, and robust trunnion assemblies to maintain headspace under heavy use. The barrel blank and rifling process are selected to give a predictable muzzle velocity and consistent throat erosion characteristics. Small engineering details that matter when you're counting groups after 2,500 rounds. The Bren also gets modularity right in a pragmatic way: quick change barrels, adjustable gas, and a comfortable rail layout that doesn't compromise barrel-to-handguard relationships. Importantly, the design balances tight tolerances with field service friendliness. Action without needing specialized tools. There are trade-offs. Ultra-tight tolerances demand higher manufacturing control and, in some markets, more robust aftermarket and support logistics. The torture test mentioned in the original review, that mud slurry, shows the Bren is resilient. But like any precision piston design, it eventually needs proper maintenance. Overall, from an engineering standpoint, the Bren 2 is an elegant compromise. It proves short-stroke pistons can be both accurate and combat-worthy when the design is executed with discipline. Alright, now let's talk about the MCX, which is one of those rare designs where modularity isn't an afterthought, it's the whole brief.
SIG didn't just bolt rails onto an existing recipe, they engineered interfaces so the rifle can legitimately be reconfigured at the operator level. That design decision shows up in every mating surface, pin, and tolerance. Tuned around a platform explicitly made for caliber and barrel swaps. The engineering headache is maintaining zero and timing across swaps. SIG solves that with tight interface geometry. Barrel extension and upper and lower mating points are manufactured to small tolerances so an upper swap doesn't magically ruin zero. That requires higher cost machining and QC, but the payoff is a rifle that actually behaves predictably when you swap a 5.56 upper for a 300 black or change to a shorter barrel. Suppressors change back pressure, which affects bolt timing and extraction. SIG addresses this with adjustable gas plugs and a system design that tolerates variance in pressure without catastrophic timing shifts. In practice, that means you can run suppressed subsonic across multiple barrels if you tune the gas, which is huge for operators who want a single chassis for many roles. Materials and manufacturing are premium. Surfaces treated to resist erosion from hot gas, alloys chosen for thermal stability, and handguards engineered to be both stiff and lightweight to avoid screwing up barrel harmonics. Toolless takedown, ambi controls, and parts interchangeability also make field maintenance straightforward. But none of that is free. You pay in manufacturing cost and complexity of supply chains. From a field perspective, the MCX feels like a system rather than a single rifle. If you want one platform that can be a CQB PDW one day and a suppressed DMR the next, MCX is practically designed for that. The trade-off? Cost, and the need to respect maintenance intervals and gas tuning when you start swapping barrels and running suppressors. I love the MCX because it nails modularity at an engineering level. It's one of those designs that makes you rethink what a rifle can be. Last in the pile, but far from least, the HK416. If you're an AR fan who's tired of direct impingement's constant cleaning, the HK feels like someone took the AR's ergonomics and taught it to be grown up. Heckler & Koch essentially grafted a short-stroke piston system onto an AR-style platform, and the engineering choices are all about preserving familiarity while solving DI's problems. From a system standpoint, the HK416 keeps the buffer tube, controls, and general ergonomics you already know, but adds a piston assembly that limits how much hot gas and carbon ever reach the bolt carrier. That's not cosmetic. It changes failure modes. With less carbon in the action, you get more consistent bolt timing over long strings, fewer stuck extractors, and generally reduced maintenance headaches in sustained fire situations. The gas system itself is well executed. A short-stroke piston with a robust gas block and regulator, and a piston that's serviceable without pulling the whole action apart. Bolt and carrier are high-quality steel with proper heat treatment and service nitriding on many models to resist wear. HK also invested in consistently produced cold hammer-forged barrels, which yields predictable harmonics and longer life, important when you're pushing accuracy expectations out of a combat-proven platform. There are engineering trade-offs to note. HK parts are often proprietary and built to a high standard, which means the supply chain and part cost are higher than a generic AR. Running, with less wiggle and bolt timing and a generally more surgical feel when you manipulate it. Operationally, the HK416 is the rifle I'd pick if I wanted AR familiarity with a big uptick in real-world reliability. It's the design that says, keep what works ergonomically, fix what doesn't mechanically. For someone who values immediate familiarity but demands better long-term duty performance, HK416 is a smart engineering compromise. So there you have it, 6 very different engineering answers to the same question. How do you build a rifle that either survives everything, shoots flatter, or adapts to every mission? Long-stroke designs like the AK buy you indestructibility and surgical simplicity. Short-stroke platforms, AUG, Bren, HK, and MCX, each chase the sweet spot between repeatable timing, accuracy, and real-world reliability. The Mini 14 reminds us that simplicity, serviceability, and predictable behavior still win hearts in jobs where complexity is a liability. If I had to boil it down, pick the tool that matches the mission. Want a weapon that never quits in a swamp? Long-stroke AK. Want compact, accurate power? AUG. Want modular, multi-purpose system you can suppress and rebarrel on the fly? MCX. Want familiar AR ergonomics with piston reliability? HK416. Want a simple, fix-it-anywhere rifle? Mini 14. Want balanced precision plus combat toughness? Bren. Which one would you take to the range and why? Drop it in the comments. Hit subscribe if you want more deep teardown vids, and as always, see you in the next one.